Let's continue our discussion of permutations with more examples. Let's see this next one. Given 4 flags of different colors, how many signals can be generated using them if a signal requires 2 flags, one below the other? Let's see the main idea of the solution without writing sentences. So this is how the flags are to appear, and 2 such flags, one on top of the other, will form one signal. And we have 4 flags available to us of 4 different colors. So the top flag can be any one of these 4, and that can happen in 4 ways. And once you have chosen the top flag, obviously that cannot be repeated to also appear here, and that is why once any one of these 4 has been chosen, then you are left with 3 flags. So the bottom flag can be chosen in 3 ways. Corresponding to each of these 4 choices of the top flag, there are 3 choices for the bottom flag, and that's why in total there will be 4 times 3, that is 12 signals. That's it. Next example, how many 2-digit even numbers can be formed using the digits 1, 2, 3, 4 and 5 if digits can be repeated? Okay, so you are allowed to repeat digits, so it's not like the previous example where flags cannot be repeated, of course. So the solution, of course, will be this. A 2-digit number has 2 digits, the units place digit and the tens place digit. And it's also given that it needs to be even. So that means the units place digit itself has to be an even integer. We only have 2 even integers available to us, 2 and 4. So the units place will be either 2 or 4. So there are 2 possibilities for that. And that's why I have written 2 here. Corresponding to each such possibility, what about the tens place? The tens place has all the 5 digits available because repetition is allowed. So even if you have 2 here, you can again choose 2 here. So that's why here we have 5 possibilities. So the total number of such numbers is 5 times 2, that is 10. Another one involving flags and signals. Find the number of signals that can be generated by arranging at least 2 flags in order on a vertical staff if 5 different flags are available. Solution. So this time we not only have different signals but different types of signals. We have signals of this type consisting of 2 flags, and their total number is 5 times 4, which is 20. You know how. For the top flag, for example, there are 5 options available, and if you have chosen one, then you are left with only 4 for the bottom flag. So that's how 5 times 4. But you also have signals of this type where there are 3 flags, and the total number of them is 5 times 4 times 3, which is 60. What is this 3? Once you have chosen the top flag and middle flag, 2 flags are gone from the available 5. So you are left with 3, so that is this 3. This is the number of options for the bottom flag. Similarly, you have signals consisting of 4 flags and their total number is 120. 5 times 4 times 3 times 2. And finally, you also have signals consisting of all 5 flags and their total number is also 120. And then you add them up and get the grand total, which is 320. Why do we add these numbers and not multiply? That is because signals of this type and this type, for example, are not related. It is, we don't have anything like this. Say, for each signal of this type, there are that many signals of this type, nothing like that. Okay, so they are not related, so that's why their numbers are added. And let's next start the exercises. 7.1. This is number 1. How many 3-digit integers can be formed using the first 5 positive integers if there are 2 parts? Repetition of digits is allowed, and in part 2, repetition of digits is not allowed. Solution, part 1, where repetition of digits is allowed. So a 3-digit number has a units digit, a tens digit and a hundreds digit. because repetition is allowed, so for each of these places there are 5 options, and that's why the total number is 5 times 5 times 5 or 5 cube, which is 125. In part 2, repetition of digits is not allowed. So if you consider the hundreds place, there are 5 options for it. So once you have chosen the hundreds place, there are only 4 options available to you to choose the tens digit, and once you have chosen that also, you only have 3 options to choose the units digit. So that's why the total number is 5 times 4 times 3, which is 60, much less than what we have in part 1. Next, number 2, how many 3-digit even integers can be formed using the first 6 positive integers if repetition of digits is allowed? Solution, so the number is a 3-digit number and it needs to be even also. So that's why the units digit should be either 2 or 4 or 6 even. So that's why there are 3 options for that. But repetition is allowed. So for the tens digit and also for the hundreds digit, each one has 6 options available. So that's why the total number of such numbers is 6 times 6 times 3, which is 108. Next, number 3. How many 4-letter codes can be formed with the first 10 letters of the English alphabet if no letter can be repeated? Solution, so these are 4-letter codes, and by now you know what to do, because letters cannot be repeated and there are 10 available letters to us. So the total number is 10 times 9 times 8 times 7, which is 5040. Next, number 4. How many 5-digit telephone numbers can be formed using all the decimal digits, that means from 0 to 9, if each number starts with 67, this is fixed, okay, and no digit appears more than once, that means repetition of digits is also not allowed. Solution, so although the telephone numbers are 5-digit numbers, but the first 2 digits are 6 and 7, so they are fixed. So the only change will happen in these last 3 digits. Also digits cannot be repeated, so 6 and 7 are gone. So from the available 10 decimal digits, 2 are gone. So for the third place we have 8 options, and once you have chosen something for the third place, you have 7 options left for you for the second place, and similarly 6 options for this final place. So that's why the total number is 8 times 7 times 6, which is 336. Looking at just this 5 digit, I mean, it's there to throw us off, to confuse us. Actually, it's just this much. And finally, we have one more, number 5. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? Solution, so the total number is 8. Why? Because each coin toss results either in heads or tails. We of course are not taking into account some other possibility. For example, the coin standing on its edge. It is very unlikely, but still it can happen. But we are not considering those things. Okay, so it's either heads or tails for us. So that's why each such toss has 2 possibilities, and corresponding to each such possibility, the second toss also has 2 possibilities, and corresponding to each such possibility for the second toss, you have 2 possibilities for the third toss as well, same heads or tails. That's why in total you have 8 outcomes.